remember our last conversation I think it was a couple weeks ago. It was me, Professor Amaduri, and Shruti from our lab. We were planning on using AirPod to do some like, kind of limited beamforming applications. I'm just now getting into the actual, custom scripting in AirPod because with the AADM challenge, it was more like you guys gave us the UAV data mule and all the necessary like helper scripts for the radio transmitter and receiver, so we didn't really have to touch any of that ourselves. So I'm just now kind of getting into making like custom scripts which interfaces directly with SRS RAN because I'm using the SRS one, not the OAI. Um, so, I've been like looking through the SRS RAN documentation on just like how to start end-to-end network. Um, I don't necessarily see anything in there for beamforming though. I do remember that you said it was the B210, the USRP B210 that's on the drone, and that has very limited beamforming capability because I believe it's only a 2x2. So I think what we discussed was having basically each transmit antenna cover like its own 180-degree hemisphere so that we could potentially target two groups in like a different location. So all that to say, would you know where to start on that problem from the scripting side of things? Like what I would need to modify in terms of like parameters for the radio scripts for SRS RAN, if that makes sense.
Yeah, we do have the fixed nodes equipped with B210 USRP, which has two transmit and two receive antennas. So you can
Mhm.
do 2x2 MIMO. And our portable nodes that we attach on the UAV, we have two types of portable nodes. Ones that are equipped with B205 Mini, which only has one transmit, one receive antenna.
Mhm.
But we also have a portable node with B210 USRP. It has a similar to the fixed node, right? It has two transmit, two receive.
Mhm.
And so in the virtual environment, like in development environment, so you can program the SDR as if you have the actual USRP connected to your experiment, but you program it as if there is actual USRP, but actually it's a virtual USRP.
Right.
But the same script that you write on the development, and when we move it to testbed, it works on the real USRP.
Okay, yeah, that's my understanding, right.
So
With the USRP, specifically, I'm just interested in how to access each transmit antenna. Like for that 2x2, if I wanted to use each antenna independently, to create that like 180-degree hemisphere on either side, is there like somewhere I should start to do that? I guess that's kind of what I'm concerned about, and wanting to look into, because I've looked in the let me see, I have the scripts pulled up here. So I see like start UE MIMO.
yeah, we do have SRS MIMO sample experiment. So if you will be using SRS RAN, then I think that's a good start.
Right. So in here, I'm just like taking a cursory glance at it. It looks like it's kind of the same setup as the CISO, in that you're just, configuring the transmit receive gain, the uplink downlink frequency, the IMSI, but I don't see anything, and also there's the number of antennas, like for MIMO configuration, it says right here. So two antennas.
Yeah.
How would I like, I guess, programmatically approach the problem of sending, like if we were doing a beamforming application, right, and we're trying to serve multiple user groups concurrently, um, how would I go about that programmatically to say this antenna, and I'm not just asking you to give me the answer, like even if you could just point me to resources on how to do this or something, but like how to designate this antenna is for this beam, this antenna is for that beam, and whatever multiple access technique. Like in the lab, we've been talking about doing some derivative of BDMA with like OFDMA. So like whatever multiple access technique, but mainly like from the scripting perspective, how to access those antennas. And you know, I also do want to mention I could be like not understanding even what I'm saying right now, but that's kind of the reason I'm asking, is just because I don't know like what's possible. So if the question I'm asking doesn't make sense, please tell me, because I'm really not sure if I'm even asking the right questions.
Yeah, I don't know the specifics of the SRS RAN. So if it supports beamforming or not. But
Okay, so it would be on the SRS RAN end of things. It wouldn't be on the AirPods side, right?
yeah, but for instance, I can give you another example. So let me share my screen. Uh, so for instance, we do have a sample experiment. So this is our the folder that we have the sample radio scripts. So if you like one of the example experiments that we have is the IQ collection. So let me
Mm, mm.
try to, yeah, this one is IQ collection, right? So for instance, like in IQ collection, you have so this so it uses this Python script, right? If you go to this
Mhm.
if you go to this folder, uh, is let me see, SCR control, do this all. So this is the Python file like that.
Oh, okay.
So this is a UHD uh, Python UHD API. It uses Python UHD API.
So
Uh,
UHD is the USRP hardware driver, right? That's how you
yes,
interface with
yeah.
the hardware. Okay.
Mhm. So for instance, like when you collect IQ data, you can configure it to collect data from both channels. When you have
Ah,
So when you have multiple channels, and the way you do it is for this example is I think you configure it under this my constants file where you have so you see here like so you have this structure here gain Rx. Like if you specify only one gain here, it will collect from one channel. But you can also, like, let's say you can say here, gain Rx is 40, comma 40.
okay. Yeah, put it in a tuple. Okay.
Yeah, it will be collecting IQ from both channels.
I see. Okay. So that's probably where to start, is getting familiarized with the UHD.
Mhm.
Because up to this point, I've just been doing research, like, you know, the SRS RAN documentation. I've read about the UHD. We've been actually working over here at UNT to get our new 5G system set up. Like we got two new PCs, so we've kind of just been like, we really haven't had access to what we need yet, but we just now got them set up. So UHD is something I'll definitely look into now.
Yeah, so if you have the actual USRP that you can play with, yeah, you can start
Hmm.
from there. Like you can uh, develop your scripts with the actual USRP. It will be, I think, um,
Would you recommend that? So we
more
actually,
intuitive.
yeah, sorry, I don't mean to interrupt you. So we did get two USRPs as well. We got the B210s, right?
Yeah.
Um, and I was reading in the SRS RAN documentation that you can do a fully simulated end-to-end network using the ZMQ. At least for the 4G stuff, you can use ZMQ. I haven't really looked too much into the 5G uh, side of things yet. But would you, in your opinion, like speaking from your expertise, would you recommend actually using the hardware to test some of these scripts as opposed to doing it through the ZMQ, like the virtual?
Yeah, I would suggest using the actual USRP because so our digital twin is assuming like it so you can program it up to the like the ZMQ level, But
Mm.
our digital TV works below that ZMQ level. Actually, it's like it goes into the IQ level. Like
Okay. Could
yeah.
you explain that a little bit? I'm kind of new to this stuff. Would you mind if
So
explaining that?
so like IQ level is like is the lowest level, like the physical layer.
That's the actual like
Yeah.
signal itself, right?
Yeah, the IQ signal is what is being transmitted from the companion computer into the USRP. And
I see. Okay.
yeah, USRP takes those IQ samples, and then it uh, converts it from digital to analog, and then for the
Right, right.
baseband signal it up converts to RF.
Hmm.
But like in our digital TV, we generate the IQ data, but instead of forwarding that IQ data into actual USRP, we forward it to a virtual USRP.
Mm.
But the way you program it is the same as if you are programming actual USRP. So
Right, right.
we work in the same level as an actual USRP in terms of a program.
I see. Okay. With the end-to-end simulated full like LTE network, you said it's below the ZMQ level. So I guess a lot of the unnecessary stuff, if you use the ZMQ, or not unnecessary, a lot of the actual data being exchanged in the network, like the LTE stack essentially isn't getting used. Is that what you're saying? It's more of just like a faux network, not really.
Yeah, like yeah, it's like ZMQ like doesn't you don't implement what is beneath the ZMQ level, like for instance the OFDM signal, the physical layer, right? It's not being
Okay.
implemented.
Okay, that makes a lot of sense. So okay. Yeah, I've been trying to determine whether I should go that route or if it would be better to use the hardware. I think just personally, I'm more of like a hands-on guy, so I like being able to like touch the thing and get it to work properly.
So
S-
if you have the physical like actual USRP yourself, and then if you know what you will do with the actual USRP, and then once you have your code developed in the actual USRP, so then from that point, like we can discuss how we can implement it in AirPower.
okay.
Yeah,
So okay.
in the test bed, it would be the same as if you are doing it in the lab, because in
Mhm.
the test bed we have actual USRPs,
Mm.
but you can also implement it before you submit it to test bed. You can implement it in the digital twin as well, where you can integrate your code with the UAV and like how they interact with each other.
Right. Now that I'm thinking about it, so by using the actual hardware, you're probably going to be able to refine whatever algorithms you're writing better too, because you're going to have the actual data on how it functions in the real world versus if, and this is just me speaking hypothetically because I don't actually know, but it would appear like if you were doing it all through simulation and virtual, that if you tried to deploy that in the real world, there might be, whatever factors due to the environment or interference sources, or maybe just due to not having tested it ever that are going to affect it negatively. Like, so I guess what I'm saying is, yeah, do it in person, like so that you can test how it would actually function in the real world. So that when we get to the deployment stage, we don't run into the problem of, oh, hey, we never tested this before. We just set up like a whole AirPaw thing. Like, does that make sense? Would you agree with that?
Yeah, I would agree. Yeah. So actually, that's what we do in our sample experiments as well. Like we first start with the actual USRP, and then we decide how we can implement
Then
it
you port it over to
in the
code.
digital twin.
Okay. Okay, that makes sense. That makes a lot of sense. Yeah, I'm new to a lot of the RF stuff. Like I've just been getting into it this year. So aside from like reading about it online through documentation, I haven't really had much hands-on. So being able to hear like how your guys' over AirPod workflow goes, I appreciate that a lot. Thank you for that.
Yeah, no problem.
Um, Okay, yeah, I think that I have a pretty good place to start, like looking at just that IQ script, the start IQ collection one. I'll check that out because that's kind of where I left off was actually going into the AirPaw scripts and just looking at how you guys started SRS RAN. I really haven't went into the Python part of it
Mhm.
yet because I figured I needed, know how to use the RF interface before actually trying to use it with Python. So I'll definitely check those out too once I can.
So if you go to the user manual, we have this section 6 with all the sample experiments and the radio 6.1, and then there is 614 UHD Python API, and one of them here is the IQ collection.
Okay,
So
so okay. 6.1.4.
yeah,
Okay.
um,
Six
so
point.
yeah, I think it talks about here. Uh, yeah, I think it doesn't talk here about using multiple channels here. But like here, as I mentioned, instead of having one gain setting here, if you have two gains, then it will record IQ from both channels.
Okay. Yeah, I haven't checked out the UHD Python. I actually didn't even realize that was there. I'll definitely have to look at that. 6.1. Okay. I think this is what I needed actually, because looking just at the bash scripts,
Mhm.
it was pretty much just like the standard launching of the SRS RAN, and I was kind of wondering like where is this all leading to? Like where's the actual back end code for this? So this puts it into perspective. I gotta check out the Python stuff.
Yeah, for the SRS code, we did have small modifications to the actual SRS code, but yeah, it's mainly SRS code, right? It's not AirPod.
Yeah, right,
Yeah,
right.
but this one, yeah, is built for AirPod.
Okay, okay. Very cool. There
Yeah,
was
you
one
can
more.
also like this
Yeah.
is one option that you have, like UHD Python
Mm,
API. You can also do GNU Radio. Is
okay.
Yeah, if you have a like GNU Radio flow graph that works with the USRPs, then you can also implement it in AirPod.
So I've looked a little at GNU Radio. To my understanding, it's like how SRS RAN and OAI are like LTE and 5G deployment, like or the stack of software you need. Like the GNU Radio is just directly interfacing with the hardware, abstracted away from any cellular protocols, right? Does that
Yeah,
make sense?
this also is also a Python code behind. So you have a visual flow graph with blocks like Simulink in MATLAB.
Oh, okay. Yeah, that'd be super helpful.
And
That'd be
then
super.
what you do is to use it in AirPower, you build Python, generate the Python code from the GNU Radio flow graph, and then you can run that Python code.
Oh, wow. Okay. That's one reason I really like Simulink actually is because you can do the block diagramming and then use like the coder to deploy it. That's actually what I'm doing for my senior design right now. A
Mhm.
lot of it is in Simulink. So if GNU Radio has that, is that built into the package, or do you have to download this visualization piece of it separately?
Yeah, the visualization also is there inside our EVM containers. But you need to run like when you SSH into the container, you need to SSH with -X option,
Mm.
with which will have the display in addition to the terminal. Like you can run GUI from the terminal, right?
Oh, okay. So yeah, you just got to SSH with the -X.
Yeah,
Okay.
but I wouldn't uh, suggest you develop your code like that because uh, it's uh, it's pretty slow when you do it like that. But what you can do is you can locally develop your flow graphs, and then just run it as a Python file in the AirPod.
Okay.
Like you have let's say you have a locally installed GNU Radio, but then you can generate the Python file from that flow graph, and then you can upload that Python file to AirPod.
Right. Okay. So it is similar to how Simulink has their coder that you can use to generate C code and then deploy that wherever.
Yeah.
Okay. So you said it's not recommended and that it's slower. Is that like the real-time performance, or is it
Yeah,
like
because
what do you mean by slow?
you forward the display. Yeah, you can try it. If it doesn't look slow, you can use it. But I think we don't advertise it in our user menu.
I see. Okay. Yeah, I can give it a shot. I'll definitely. It sounds interesting just because of how much of a fan I am of Simulink. So I appreciate you telling me about that. I'm a very visual person. Like if you give me pictures of stuff, I'm usually good, but I like having diagrams and pictures. Simple brained.
Yeah, this actually this the channel sounder that we use in the Adam challenge is actually a GNU Radio flow graph.
Oh, okay. So that'd probably be a good one to check out then. The channel sounder.
Yeah, this you have a GNU Radio transmitter and a GNU Radio receiver
Right. Okay.
running in the background.
Sounder. Okay. Sorry, I'm just writing some of this stuff.
So you can also find the flow graph here. Is STR control is there is a channel sounder V3 folder in the.
Oh, okay. Okay.
And then here you can see there are see these GRC files. So the GRC files are the GNU Radio flow graphs, and then the Python files are the Python files generated from the flow graphs.
Okay, sorry. Which ones are the flow graph? The GRC
Yeah,
files?
the GRC extensions are for the flow graph, and you will see the same file name but with the Py extension. Those are the Python files generated
Ah,
from the flow graph.
okay, I see. So all the GRC files are radio flow graphs, and then they all have like a corresponding
Yeah.
Python file that got generated. Okay.
Yeah.
And what directory were you in right here? Channel sounder?
It's in so you have like in it says here profile software, but it's in the experiment that you SSH into is the root / profiles folder. STR control will be there.
Okay. So we got root agent. Yeah. Oh, okay. Profile software. Gotcha. Files. Yeah, there's so many directories that I'm just asking for specific names so I know for sure because navigating through the container, there is a lot. So I just needed.
Yeah, actually, I can show it from example here. So
Oh, that'd be great. Yeah.
so this is the root folder. So you see there's a profiles. If you go inside the profiles, and if you do ls, there's the STR control is here.
Okay, profiles, SDR control. Gotcha.
And then if you go inside here, there is the channel sounder is here.
Okay. Perfect. Do you know what those the YAML file or the YML files are? Are those like configuration?
So actually these are so inside the receiver flow graph we have a custom block. Like you can put Python code inside your custom block.
Ah, okay.
Yeah,
I see.
that's needed for running that custom block.
I see. I see. Okay.
Or
Maybe like
actually,
the
yeah, maybe no, actually no, this is not the, so this is the custom block. So this one is I was experimenting with this. So this is like so when you have multiple blocks and the flow graph becomes crowded, what you can do is you can combine multiple blocks into a single block. Like I think it's called hierarchical.
like a subsystem kind of thing.
Yeah, yeah,
I see. I see.
yeah. To make the flow graph look
Just clean it up a little.
yeah. Mhm.
Right. Okay. Yeah, that makes sense.
I think we don't use this for the channel sounder. The sample code I think doesn't use it.
Okay. All right. So yeah, I'll check these out. Do you have any, so I have the channel sounder v3, like I'll check out some of the other stuff in the SDR control folder. Would you recommend like any other specific scripts to check out and just like look how the usual workflow goes, I guess, when programming this?
Yeah, I think so we have a software like SRS RAN or OAI, which is a non-airfile software,
Mm.
but we have sample experiments with that, and we have GNU Radio, we have the UHD Python. I think these are the three main sample experiments we have for SDR.
Okay, I have the UHD and then the GNU. What was the other one? Sorry.
SRS RAN, and like we also have OAI, right? Open Air Interface.
Oh, AI. Okay.
Is like the alternative to SRS RAN.
Right. Okay. Okay. Yeah. So I'll look into the Python side of because the specific experiment I was looking at was the LTE flying base station with SRS RAN. So I didn't get actually into the Python back end of it, just in the SRS RAN side. So I'll look in the Python side of that to get more familiarized. Yeah, I feel like I have a pretty good starting point now for UHD, GNU, and SRS RAN. Cool. Cool. Yeah. I think that's all I have. Thank you so much for your help. That
No
trying to learn this stuff like without a guide is very difficult. So I really appreciate it.
Yeah, no problem.
Thank you, Skylar, for popping in. Thank you so much, and look forward to helping you in the future. If you have questions, please feel free to email us. You saw there is airport operations email. You can email us. You can schedule office hours, or you can just show up on Tuesday.
Okay, cool. Yeah. Thank you
Okay.
guys so much. I appreciate it. Y'all have a nice
You're
day.
welcome.
No
You're
problem.
welcome.
Bye.
Mhm.